Hello everybody. In this video we will learn about combining functions, a part of the section 2.7. Two functions f and g can be combined in many ways. That is nothing but you perform arithmetic operations on the functions. So but you may wonder that what does it mean to say f plus g or f minus g or f times g and f divided by g. So you know that f and g are just names of the rules that you need to follow. So how can you operate names of rules? So if I ask you to operate Nirmala with Murthy, so Nirmala plus Murthy, it's not like Nirmala Murthy. So it is something like you combine the rules and operate it on the elements of the domain. So whenever you are performing operations like this is called as sum and this is called as difference and this is product and this is quotient. So whenever you are operating, whenever you are asked to perform these operations, it is nothing but you are operating the combined effect of the f and g on the domain. So if f has a domain A and f has the domain A and g has domain B, so you perform all the operations, all these operations on domain A intersection B. So now to state whatever I said now, if f and g be functions with domain A and B, then the functions f plus g, f minus g, fg and f divided by g are defined as follows. F plus g will act on x. So this is nothing but you are combining the functional values or adding the functional values after you apply f on x and g on x. The same thing you do it with the difference. So this would be equal to f of x minus g of x. So then when it comes to product, fg of x is equal to f of g of it is f of x times g of x. So product f of x times g of x. So then f divided by g of x is equal to f of x divided by g of x. So all the operations are performed on the domain A intersection B, and this has something that is special. Domain is definitely x belonging to A intersection B, but there is a restriction on the denominator, that is g of x cannot be equal to 0. So this is how you perform all the operations. So let us do some examples so that you will understand how to perform the operations. So this is exercise number 10 in your book. You are asked to combine functions, that is you are asked to find f plus g, f minus g, fg and f divided by g and also their domains. Okay, so 10 has f of x is equal to 3 minus x square, g of x has x square minus 4. Okay, so f plus g of x by definition is f of x plus g of x. So that would be equal to 3 minus x square plus x square minus 4. So if you cancel out negative x square and positive x square, that would be equal to negative 1. Okay, so then f minus g of x is f of x minus g of x. So this is equal to 3 minus x square minus x square plus 4. So this is 7 minus 2x square. Then when you apply or do the product of two functions, so it is f of x times g of x. So this is equal to 3 minus x square times x square minus 4. So you have to apply the FOIL method here. The first terms are 3x square. The last terms or the end terms are, outer terms are 3 and negative 4. So that would give us negative 12. Then minus x to the power of 4 plus 4x square. So the 3x square and 4x square are like terms. So if we add them, you will get 7x square minus x to the power of 4 minus 12. So that is the product. Then moving further, we have to divide f of x, f divided by g of x is equal to, so this is, okay, I'll write it properly. So f divided by g of x is equal to f of x divided by g of x. So this is equal to 3 minus x square divided by x square minus 4. So if you expand the things, like factorize it, you will get the numerator to be x minus square root of 3 times x plus square root of 3 divided by x minus 2 times x plus 2. So there is nothing more we can cancel out or nothing more we can do, but you can do a proper division of polynomials. So that is the traditional division, 3 minus x square. So x square minus 4 divided by x square minus 4, you get 1. So negative 4 plus x square. So x square and x square will get cancelled. You are just left with negative 1 as a reminder. Okay. So that is, if you express this, you have to express this as a mixed fraction. So no need to do that. We can leave this thing like this, like after factorization. If further simplification is not possible, just leave it as it is. Okay. So now we are also asked to find their domains. Okay, let us do that. So domain for everything up to product is just A intersection B. That is domain of A, domain of F intersection domain of G, right? So let us find out what is the domain of F. That is, what is the function? 3 minus x square, right? So 3 minus x square can be, it is in the numerator, and it can take any real value as a value. The x can take any real number as a value. Therefore domain of F is nothing but R. So R. Domain of G is also R. So R intersection R is R. So domain of F plus G, FG, F minus G is R. Okay. So but let us do the domain of F divided by G. F divided by G is set of all x belongs to R such that G of x is not equal to 0, right? So when is G of x equal to 0? when x is equal to plus or minus 2. Correct? Because g of x is x square minus 4. Therefore, x square minus 4 is equal to 0. When is it? When x square is equal to 4, when x is plus or minus 2. So we are eliminating these two values. Therefore, domain of sorry, I didn't write the statement. Okay, so domain of f divided by g is nothing but all those x which belongs to R such that g of x is not equal to 0. That means okay, x is not equal to negative plus or minus 2. So that is all real numbers except plus and minus 2. So this is how we perform the algebraic operations on given functions. We will do another one, number 14 in the book. So this is little this has square root and little complicated. So if I consider f of x is equal to square root of 16 minus x square and g of x is equal to square root of x square minus 1, we have to perform all the operations, that is add them, we have to add them, subtract them, multiply them and divide them. Also find the domains of each of the combined functions. So f plus g of x is nothing but f of x plus g of x. So if I add them, so I will be getting 16 minus x square plus square root of x square minus 1. I can't combine them because you have square root and you have an addition sign that is separating both of them. Let us see if we can simplify them. I don't think we can even simplify them because we don't have common factors. They can be factored, like the first term can be factored as x minus 4 times x plus 4, and the last term can be factored as x minus 1 plus x plus 1, sorry, x minus 1 times x plus 1, but that doesn't help, or there are no common factors to take out and simplify it further, so we will leave this thing as it is. So even difference is one and the same. Just have to write square root of 16 minus x square minus square root of x square minus 1. Then fg of x is multiply square root of 16 minus x square times square root of x square minus 1. Now we can do something about this. That is, we can multiply and apply one single square root. So that would be square root of 16 minus x square times x square minus 1. So this is possible. Is further simplification possible? We will see that. Okay, 16x square minus 16 minus x to the power of 4. I am multiplying the terms, so that is plus x square. Okay, so we will be getting okay, I don't think there is any use in doing this. We will get negative x to the power of 4. Yeah, there is no use in multiplying. I will leave this thing after factorization. So this would be 6 square root of 4 minus x times 4 plus x, applying the special factoring formula, that is a square minus b square, and x square minus 1 would be x minus 1 times x plus 1. Okay, so I'll leave it here. Then when we divide f divided by g of x, so this would be f of x divided by g of x. So that gives us square root of 16 minus x square divided by square root of x square minus 1. That is nothing but square root of 4 minus x square root of 4 plus x divided by square root of x minus 1 times square root of x plus 1. Okay, nothing further can be done here. So we are also asked to calculate domain. So we will first calculate the domain of f of x. So domain of f of x is first, what is f of x? F of x is square root of 16 minus x square. You know that we can't calculate, we haven't yet defined the square root of a negative number. So when will the term inside the square root, that is the function inside the square root, be negative? Whenever the x square value is greater than 16, right? So whenever it is greater than 16, we have something that is that would be greater than 16. So that means x should be greater than plus or minus 4. So x cannot be greater than plus or minus 4. Greater than or less than, both, right? So x cannot be greater than plus 4 and x cannot be less than minus 4. Correct? So in that case, we get in these two cases we get something that is negative value inside the square root. So we have to avoid this. This is not possible. Therefore we consider all the intervals in between negative, close interval -4 to +4. Correct? So then speaking about domain of g of x, we can also use a graph for this. So I will use a graphing calculator just to break the monotonous thing. So g of x domain is g y is equal to square root of x square minus 1, right? Minus 1. Okay. Oh, I'm sorry, I just typed it wrong. Okay, y is equal to square root of x square minus 1. So x square minus 1, you can see the x values are running in between -1 and +1. So with the graphs, therefore domain of g of x is -1 and +1. That is closed interval -1 to closed interval 1. So what is the intersection of, so domain of f plus g, f minus g and fg are all intersection of a. If a is closed interval -4, 4 and b is -1, 1, it is a intersection b. Correct? So what is the intersection of -4 to 4? Intersection -1 to 1. So that is -1 to 1 itself, because b is a subset of a. So this would be -1, 1. But f divided by g has a separate domain. It is all those x which belongs to a intersection b, that is closed interval -1, 1, such that g of x is not equal to 0. So when is g of x is equal to 0? When x is -1 and x is +1. Then x square minus 1 will be 0 and square root of 0 will be 0. So we are avoiding -1 and +1. So that reduces to open interval -1 and +1. So this is how you perform all the algebraic operations as well as find out the domain of the functions. You can either find the domain using a graphing calculator, or I just did it just to break the monotonicity. If you only do it if you are asked to find the domain using a graphing calculator. If not, I would recommend you to give a proper explanation by analyzing the permissible values that x can take in the function. So the next video will be on composition of functions. So how you will see how product is different from composition of functions. I will meet you very soon. Thank you for listening.